Hey everyone, today we are going to solve the LeetCode question, happy number. Okay, I think there are 2 points to solve this question. First point is how do you obtain the digit in the ones place? Second point is how do you move from the ones place to the tens place? Let me explain one by one. Okay, first point is how do you obtain the digit in the ones place? So there are 3 numbers, 15, 28, 10. So in this case, ones place is 5 or 8 or 0. So how do you get these numbers? So my strategy is to use remainder after dividing by 10. So 15 divide 10 should be 5. So this is a remainder. And 28 divide 10 should be 8. And 10 divide 10 should be 0. So look at these numbers. So we successfully get a number from one's place, right? So we can use these numbers. And let me explain the second point. So second point is how do you move from one's place to the tenth place? So actually it's similar to the first point. We use answer by dividing 10. So that means 15 divide 10 should be 1, right? And 28 divide 10 should be 2. And 10 divide 10 should be 1. Look at the 10th digit. So 1, 2, 1. So we successfully get like a 1, 2, 1. So we use those two ideas to calculate a happy number. So let's see one by one. Okay, so let's think about the input is 19. So first of all, we will get number from one's place. So 19 divided 10 should be 9, right? And then next, we calculate like a 2 to the power of 9. So 9 multiplied by 9. So this is a plus equal, actually, and 81, right? And then we will move from one's place to ten's place. So 19 divided 10 should be 1, right? And then this one goes to this position. So 1 divide 10 should be 1. And then 2 to the power of 1. So 1, 1. So that should be 1. So plus equal. So that means 82, right? And then 1 divide 10 should be 0. So if we reach 0, we finish. So current output is 82. So it's not 1. So that's why let's continue to calculate happy number with 82. So let me change the color. And then next input is 82. Divide 10 should be 2, right? And then 2 to the power of 2. So that is 4. And then current input is 82. Divide 10 should be 8. And then 8 goes to this place. And 8 divide 10 should be 8. So 8 multiply 8 should be 64. So we have 4, so that's why 68. And then, so now input is 8. So 8 divide 10 should be 0. So we reach 0. So current output is 68. So it's not 1. So let's continue. So let me change the color. So next, 68. 68 divided 10 should be 8. And 8 multiply 8 should be 64. And then, so the current input is 68 divided 10 should be 6. So next input is 6. And 6 divided 10 should be 6. And 6 multiply 6 should be 36. So that is 64, 100. And then current input is 6. So 6 divided 10 is 0. So we finish iteration. And the current output is 100. It's not 1. So let's continue. So there's no color. And okay, purple. So 100 divide 10 should be 10. Not 10, 0. And then 0 multiply 0 should be 0, right? And then 100 divided 10 should be 10. And then this 10 goes to here, and the 10 divided 10 should be 0. And 0 multiplied 0 is 0, and we have now 0, so output is now 0. And then 10 divided 10 should be 1. And the next input is 1. So 1 divided 10 should be 1. And 1 multiplied 1 should be 1. So now we have 0. So output is now 1. And then current input is 1. So 1 divided 10 should be 0, right? And then we finish. And the current output is 1. So actually, this is a happy number. So we should return, I think, true, right? We should return true or false, right? So I think we should return true in this case. Yeah, so that is a basic idea to solve this question. So let's jump into the code. Okay, so let's write the code. First of all, create a visit equals set. So actually, I forgot to explain this. So we use set to prevent revisiting the same number. If we find the same number in set, so that means we are in the infinity cycle. So in that case, we should return false. So that's why we use set. And then after that, so let's iterate through one by one. While current number not in visit. So in that case, first of all, add current number to visit so that we can prevent like an infinity cycle. So add and the current number. And let's calculate the next number. So n equal get next number. So we will create this function later and passing the current number. And if n equal 1, in the case, we should return true. And if we don't find 1 with this while loop, in that case, we should return false. So let's create a get next number as an inner function. So def get next number and taking n. So let's say output equals 0. And then while n, so that means n is not 0. So in that case, we continue. So first of all, we will get a number from one's place. So let's say digit equal n % 10. And then after that, output plus equal digit. And in Python, if we use like a asterisk 2, in the case, so for example, digit is 9 in the case, so this calculation should be 9 multiply 9. And then after that, so we have to move from 1's place to 10's place. So n should be n divide 10. And then return output. I think that's it. So let me submit it. Yeah, looks good. And the time complexity of this solution should be order of log n. And the space is order of k. So let me skip my explanation because it's wrong. So I wrote down the reason in my post. So you can check it in the description below if you want. Yeah, so let me explain the second solution. Okay, solution 2 is based on almost the same idea as solution 1. Question is, how can we quickly find the number 1? So my answer is to use 2 pointers. So let's think about the input is 19. So next number is 82 and 68, 100, and 1. And then we use 2 pointers. So one is, let's say, a slow pointer. And then the other is fast pointer. And let's move 2 pointers. Every time slow pointer move once and the fast pointer move twice. If we stop, if both pointers are same number. So let's see one by one. So as I told you, slow pointer move once. So just calculate 19 and then get 82, right? So slow pointer move once and then first pointer moved twice. That means we calculate twice. So first of all, we calculate 19 and I get 82. So move next. Oops, this is first pointer. And then first pointer calculate again with 82. And I get, I think, 68. So that's why now first pointer is 68. And then slow pointer move once. So calculate 82, get 68. And then first pointer move twice, calculate 68 and 100, and now 1. And then calculate 68 for a slow pointer and move next. And the first pointer calculate with 1. So 1 always like produce 1, right? 1 multiply 1 should be 1. So we calculate twice. So that means it's like a creator 1 and a creator 1. And then now first pointer is 1. And then slow pointer calculate with 100 and I get 1, right? And then first pointer again, 1 multiply 1, create 1, 1 multiply 1, create 1. So still 1. Now slow and the first pointers are both 1. So that means 19 is a happy number. So moreover, if first pointer is 1, we can actually immediately return true. So when we have first pointer here, so first pointer is 1, right? So in that case, we can immediately return true because 1 produce 1, and we know that in the end, slow pointer will become 1 at some point because a slow pointer will touch each number one by one. Easy, right? So, but by the way, why do we use 2 pointers? So in solution 1, I use set to prevent revisiting the same number. So in other words, I try to prevent infinity looping. So I'm trying to achieve the same things using 2 pointers. So to prove that, let's see false case. Okay, so let's think about the input is 20, and the slow pointer, first pointer start from 20. So first of all, slow pointer calculate 20 and move once, and the first pointer calculate 20 and move once, and calculate 4, move once, and then next slow pointer calculate 4 and move once, and the first pointer move calculate 16 and move once, and calculate 37, move once, and then slow pointer calculate 16 and move once, and the first pointer calculate 58 and 89, and then slow pointer calculate 37, and the first pointer calculate 145 and 42. And then after 42, so that should be 16 plus 4, right? And 20. So that is 20 here. So we so first pointer move back to 20. And then calculate 58 with slow pointer. And then first pointer calculate 20 and 4. And the slow pointer calculator 89, and the first pointer calculator 16 and 37, and the slow pointer calculator 145, and the first pointer calculator 58 and 89, and the slow pointer calculator 42. So slow pointer now move back to 20, and then first pointer calculator 145 and 42. So first pointer move back to 20. The first pointer touched all numbers and we didn't find 1. Now the slow pointer and the first pointer are both 20. So that means the first pointer has calculated all numbers and looped back around because the first pointer caught up with the slow pointer from behind. So that's why we can return false in this case. Yeah, so that is a basic idea to solve this question. So let's jump into the code. Okay, so let me modify solution 1. So we don't need a visit. And let me delete here. And we use a get next number. And first of all, calculate a throw pointer. So throw equal get next number, and passing the current number n. And let me copy this and calculate a first pointer. So we use get next number twice. So equal get next number and get next number and passing the n. And then after that, while throw is not equal first, so we continue. But this is the same idea as solution 1. So first of all, if first pointer equal 1, we can immediately return true. If not the case, we actually do the same thing like this. And let me copy this and change throw number and first number. Yeah, actually that's it. After that, return throw equal 1. In that case, we should return true. If not, we should return false. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be order of log n. And the space is, I think, 01. Yeah, so that's all I have for today. Please support me with the actions such as comment and hitting like button. I'll see you in the next question.